Right, so hi everyone and welcome to another episode of Moyo. So as we prepare for the Csec exam, which is in the next few days, what we're going to do today we're going to look at transformations. Transformations, we know it's a topic that comes in the exam almost every year. We want to ensure that we're clear on transformations and understanding questions in relation to transformations. Alright, so let's go. So we will be looking at questions that will involve the topics translation, reflection, rotation, glide deflection, enlargement. So let's look at this first question here. The diagram shown below shows a trapezium. So this is our trapezium. Which we will label A on the square grid. And what they want us to do, they want us to, on the diagram above, draw the image of A after it undergoes a reflection in the line x equal to -1. So you want to show reflection of that trapezium A in the line x equal to -1. So the line x equal to -1 will be a vertical line passing through -1 on the x-axis. So this is the line x equal to -1. And if we have to reflect that trapezium about that line, then what we simply do, we're going to take each vertex of the trapezium and we're going to count the number of positions from the object point to the mirror line will be the same number of positions from the mirror line to your image point. So this will be, let's count, 1, 2 units from the object point to the mirror line. And this will be 2 units from the mirror line to image, 1, 2. That's where that first point will be located. Of course, let's take a second, we're going to count 1, 2, 3. So we're going to count 3 positions from the mirror line to image, 1, 2, 3. Let's do the same for that point. So we're going to count the same number of positions from the object point to the mirror line with the same number of positions from the mirror line to image. This will be 1, 2, 3, 4, 1, 2, 3, 4. And the last, we're going to count 1, 2, 3, 4, 1, 2, 3, 4. So this here will be this will be the image of A, which we're going to call A prime. And that shows a reflection above the line x equal to -1. So let's see the other part of the question. We want to translate the object A with vector 4, -7, and we're going to label that A double prime. So we want to translate A, so translations, you want to translate A, good, to A double prime using the translation vector. The translation vector given in the question, it is 4, -7. So how are we going to translate A to A double prime? So when we translate it, of course it represents the movement of the vector. So 4 will represent x, -7 will represent y. And because it's positive 4, it means we're going to count 4 places to the right. And because it's -7, we're going to count 7 places downwards. Alright? If x was negative, you will count to the left. And if y was negative or positive, you will count upwards. Alright? So in this case, x is positive, so we're going to count image of A, which we're going to call A double prime. And this shows a translation using the translation vector 4, -7. So that's question 1. Let's look at the next question. So we have here 2. So we want to show, state the coordinates of P and Q. So 1, so to simply state the coordinates of P, this is P here. So we have, let me draw the outline, the shapes. So we have PQR. So this is P, this is Q, and that's R. And we also have P prime. So this is P prime. We have Q prime. and we have R prime. Good? So that's our triangle PQR, P prime, Q prime, R prime. So the first part of this question asks us to state the coordinates of P and Q. So P, the coordinates will be simply 2, and this here of course will be 1. So this is 2 on the X, 1 on the Y will be the coordinates of P. So we have 2 on the X, 1 on the Y will be the coordinates of P, 2, 1. The coordinates of Q will be 4 on the X. So we'll start with your X coordinate first. So 4 on the X and move across to our Y. This will be 3 on the Y. So 4 on the X, 3 on the Y. So the coordinates of Q will be 4, 3. Then it asks us to describe fully the transformation that maps triangle PQR onto triangle P prime, Q prime, R prime. So this clearly is, if we look, it is a reflection. So part 2, this here is your x-axis. So this is your x-axis, which is your mirror line, and the x-axis can also be stated as y equal to 0. So as an equation, y equal to 0. So the x-axis here will be your mirror line. And if we look, when we count the number of positions from the object to the mirror line, we have the same number of positions from the mirror line to the image. This is P1 unit from the object to the mirror line, 1 unit from the mirror line to image. This is 1, 2, 3 units from the object to the mirror line, 1, 2, 3 units from the mirror line to image. This is 1, 2, 3 units from the object to the mirror line, and this will be 1, 2, 3 units from the mirror line to image. So this clearly is a reflection in the line y equal to 0, or we can say, or a reflection in the x-axis. So any one of the two will be right. Let's look at part 3. They want us to write down the coordinates of the image of R and Q under the translations. We have a translation T, whose translation vector it is 3, -6. So what we want to do is Alright, yeah, so sorry about that. So let's continue. So we want to translate this, the points R and the Q. So this is R and this is Q. So we want to translate under the translation vector, which is 3, -6. So to do so, we are going to start with R, and if we are translating, because it's positive 3, we're looking at X, Y. X is positive, so it means we're going to move 3 places to the right, and -6 means we're going to move 6 downwards. So let's look at R. So we're going to move 3 places to the right, 1, 2, 3, and we're going to move 6 places downwards. This is 1, 2, 3, 4, 5, 6. So we know R. If we have to write down the coordinates of the image of R. So the image of R, if R we have initially as this is 1, 3. Then R prime, when we translate using the translation vector 3, -6, will be here. This is R prime, so R prime will be located just on Q prime. So that will be 4, -3. Let's do the same for Q. So I'm going to move 3 places to the right because it's positive 3. So this will be 1, 2, 3. And I'm moving 6 places downwards. So this is 1, 2, 3, 4, 5, 6. So this here will be Q prime. So Q, initial coordinates will be 4, 3. And Q prime will be, this is Q prime here, this will be 7, -3. So 7 on the X and -3 on the Y. Alright, so Q prime, 7, -3. Alright, let's take the next question. So we have here, so the diagram below shows a triangle PQR. So we have that triangle PQR and highlighted. This is so we have P, we have Q, and we have R. So we have that triangle PQR, and they want us to state the coordinates of R. So let's state the coordinates of R. So part 1. They want us on part A, state the coordinates of R. The coordinates of R, this is located at 3 on the y-axis. So therefore, because it's at 3 on the y-axis, then the coordinates of R will be 0, 3. And let's look at the next part of this question. It states, on the diagram above, draw triangle P prime, Q prime, R prime, a reflection of PQR on the line y equal to 1. So where's the line y equal to 1? So this is 1 on your y-axis. So the line y equal to 1 will be a horizontal line drawn through 1 on the y-axis. So that's the line y equal to 1. So it's a horizontal line passing through 1 on the y-axis. And what they want us to do, they want us to reflect PQR to P prime, Q prime, R prime about that line y equal to 1. So we have to reflect about that line. Just a simple case of counting the number of positions of the object to the mirror line with the same number of positions from the mirror line to the image. So this is what? This will be 1, 2. And this is 1, 2. So this is R prime. Let's look at P. So I'm counting 1, 1. This is P prime. Let's count Q. This will be 1, 2, 3, 4. And I'm going to count 1, 2, 3, 4. So that's Q prime. So when I connect, I'm going to have P prime, Q prime, and R prime, which is a reflection of PQR about the line y equal to 1. So let's look now at, they want us to draw P double prime, Q double prime, R double prime, which is a reflection of triangle P prime, Q prime, R prime about the line x equal to 0. So where is x equal to 0? So reflection about the line x equal to 0. So x equal to 0 is the y-axis, which is a vertical line passing through the origin, which is also known as the y-axis. So this is the y-axis here. So if we have to reflect P prime, Q prime, R prime about the y-axis x equal to 0, then what are we going to do? This is simply a case of reflecting about the line, and what are we going to do? Now, R prime, because it is on the mirror line, it remains the R double prime will be on the mirror line x equal to 0 or the y-axis. So this will be changed. This will be R double prime. So both R prime and R double prime will be at that point, which is 0, negative 1 on the y-axis. So let's reflect P prime and Q prime, so I'm going to count. This will be 1, 2, so 2 units from the object to the mirror line, and it's going to be 2 units from the mirror line to the image. That will give us P double prime. Let's do the same thing for Q prime, so I'm going to count. This will be 1, 2, and I'm going to count 1, 2. So this is Q double prime. Yeah? So let me connect. So this will be, right? And that there shows a reflection of the triangle P prime, Q prime, R prime about the y-axis or the line x equal to 0. So show a reflection about that line. Yes, so first to show reflection about the line x equal to 0 of P prime, Q prime, R prime, of course reflection about that line will take us to P double prime, Q double prime, R double prime shown. Alright, let's move on to the next. So we have here they want us to state the coordinates of R and R prime. So we have this triangle here. This is R, this is S, that's T. This is R prime, S prime, T prime. And what they want us to do is to write down the coordinates of R and R prime. So we're looking at the coordinates of R and R prime. So this is question 4. So the coordinates of R and R prime, coordinates of R, clearly this is 1, this is 2, 3, 4, 5, 6, 7, 8. So the coordinates of R will be 2. And this will be 4. 2 on the x, this is 1, 2, 3, 4, 5, 6, 7, 8. This is going to be 2 on the x and 4 on the y. So that's R. And what does it state? What are the coordinates of R prime? So R prime, this is exactly at 2 on the x-axis So the coordinates of r prime will be 2, 0. Alright? Let's look at next part of this question, part 2. Describe completely the transformation which maps triangle RST onto triangle R prime S prime T prime. So that there simply will be a reflection in the line y equal to 2. So the line y equal to 2 is here. This will be a horizontal line passing through 2 on the y-axis. So that's the line y equal to 2. So a horizontal line passing through 2 on the y-axis. So for us to describe fully, or describe completely, this is a reflection in the line y equal to 2. Alright? Let's move on to another. So on the graph below shows triangle LMN and triangle L prime M prime N prime. So this is triangle LMN. Let me quickly highlight it here. LMN, that's triangle LMN, and we have triangle L prime M prime N prime. Right? And what I want us to do is describe fully the transformation that maps triangle LMN onto triangle L prime M prime N prime. So the transformation is simply, again, a reflection in the line, and if I am to draw a vertical line passing through 7 on the x-axis. This here is the line x equal to 7. So for me to describe part 1, they want me to describe fully the transformation. So this would be a reflection in the line x equal to 7. So reflection in the line x equal to 7 is the transformation that marks triangle LMN onto triangle L prime, M prime, N prime. So next, on the answer sheet provided, draw triangle L double prime, M double prime, N double prime, the image of triangle LMN after a translation. So part 2, so we have here a translation which is 0, -3. So they want us to translate triangle LMN onto triangle what we call L double prime, M double prime, N double prime about the translation vector 0, -3. And that will be, so let's translate LMN to L double prime, M double prime, N double prime using this translation vector. So 0, -3 simply means we have no horizontal movement, but we have only vertical movement. And because it is a -3, remember this is x, that's y. And because it is -3, it means we're going to move 3 places downwards. So let's take L. So I'm going to move 3 places downwards. 1, 2, 3. That's L double prime. Let's take M. I'm going to move 3 places downwards. 1, 2, 3. That's M double prime. And let me take N. I'm going to move 3 places downwards. This is 1, 2, 3. That's N double prime. So when I connect, this is L double prime, N double prime, N double prime. Alright? So this here is the translation of LMN using, of course, the translation vector 0, -3 to L double prime, N double prime, M double prime. The next part of this question, name and describe a combination of two transformations which may be used to map L double prime, M double prime, N double prime onto L prime, M prime, N prime. So the combined transformation here, this here is a translation, if we do the reverse, moving from L double prime, M double prime, N double prime to LMN, that's a translation. And of course, moving from LMN to L prime, M prime, N prime, this is a reflection about the line x equal to 7. So translation, and of course the translation here will be 0, 3. We have to move from L double prime, M double prime, N double prime to LMN. That's a translation which will be 0, 3. And of course, from LMN to L prime, M prime, N prime, that's a reflection in the line x equal to 7. So when we have a translation and reflection occurring, a combination of the two, that is known as part 3, a glide reflection. So you have a glide reflection, showing a translation followed by a reflection, or it can be the reverse reflection followed by translation. Alright, let's look at another. So we have this triangle JKL, JKL. So let me highlight the triangle. So we have our triangle JKL, and we have our triangle J prime, L prime, K prime. And the question asks to state the coordinates of the vertex of J in triangle JKL. So we want the coordinates of J in this triangle, JKL, JKL. So the coordinates of J will simply be -4. So this is -1, -2, -3, -4, -5. So this is -4. Of course, this is 1, 2, 3. So it's going to be -4 on the x, and it's going to be -1 on the y. So it's going to be -4, -1 over the coordinates of G. So they ask us next to state the length of the side K prime, L prime in triangle J prime, K prime, L prime. The length of K prime, L prime, so the length part 2. So the length of K prime, L prime, and that will be equal to 2 units. This is 2 units. So we have 2 units. So if we subtract 1 from 3, it will give us 2 units. Representing your length. You can put 2 centimeters if you wish. Alright, so describe for me a single transformation that maps JKL onto J prime, K prime, L prime. So we want us to describe a single transformation that maps triangle JKL onto J prime, K prime, L prime. And that transformation will also be a reflection, but look at it, a reflection in the line y equal to x. Y equal to x will be, so the line y equal to x. If I am to take, let's take some coordinates on the, let's take some x coordinates. Let's take, for example, x equal to, setting up a table, let's take 0, let's take -2. So I'll take some negative values. Let's take -3, sorry, -2, -1, 0, 1, 2, 3. So when x is negative 3 and I am to substitute x equal to negative 3 to my equation of the line y equal to x, if I replace x with negative 3, then y will be negative 3. If I replace x with negative 2, then y is negative 2. If I replace x with negative 1, then y is negative 1. If I replace x with 0, then y is 0. If I replace x with 1, then y is 1. If I replace x with 2, y is 2. If I replace x with 3, y is 3. So look at what's happening here. So when I am to plot these points, my first point is negative 3, negative 3, negative 3, negative 3. This is my first point. This is negative 1, negative 2, negative 3, negative 4. So my first point is negative 3, negative 3. My second point is negative 2, negative 2. My third point is negative 1, negative 1. My fourth point is going to be 0, 0. So 0, 0. That's at the origin. My fifth point is 1, 1. This is 1, 2, 3, 4, 5. So 1, 1 is here. My sixth point is 2, 2. And the last point, let's plot 3, 3. So when I connect those points, I'm going to get a straight sloping line, that line sloping of course, and that line which passes through the origin will be y equal to x. So my mirror line here, it is y equal to x. And this simply shows for us to state what is the single transformation that maps JKL onto J prime, K prime, L prime. That single transformation is simply a reflection in the line y equal to x. And you can also use, there's the rule for reflection in the line y equal to x. The rule is this: if you have x and y coordinates, then simply for reflection in the line y equal to x, what we're going to do is just simply switch the coordinates. So if it's x, y, it becomes y, x, and we can test it and see. Let's take k, whose coordinates are negative 1, 1. And if I am to switch them, then k prime will be 1, negative 1. So if I plot 1, negative 1 will be k prime. If I am to take L, whose coordinates are negative 1, 3, then L prime, if I am to switch my coordinates, this will be 3, negative 1. Let's check. 3, negative 1 will give us L prime. Likewise, J, whose coordinates are 4, 1, negative 4, sorry, 1. And if I am to switch them, J prime will give us 1, negative 4. If I'm to plot, I'm going to see 1, negative 4 will be J prime. So we can use this rule. This is a rule for reflection in the line y equal to x, just to confirm that it is that form of transformation. Or if not, if you plot your points for the line y equal to x, you can clearly see reflection taking place about that line. Yeah? So let's look at the next part of this question. State the coordinates of J double prime, K double prime, L double prime, the image of triangle JKL on the translation 5, negative 3. So part 4. So we have here translation. Five, negative 3, and we want to translate. JKL under that translation vector 5, negative 3 to give us J double prime, K double prime, L double prime. So you know what 5, negative 3 means? This is your xy. X, of course, means you're moving 5 to the right. negative 3 means you're moving 3 downwards. So this is your translation. This is how we translate. So 5, of course, let's start with J. This is 1, 2, 3, 4, 5. So that's 5, and you move 3 downwards. 1, 2, 3. So this is J double prime. So I have J double prime there. Let's look at K double prime. So I'm moving 5 to the right. 1, 2, 3, 4, 5. And I'm moving 3 downwards. 1, 2, 3. So this here it is K double prime. So we have K double prime. And let's take now L double prime. So I'm moving 5 to the right. So this is 1, 2, 3, 4, 5. 5 to the right. And I'm moving 3 downwards. So this is 1, 2, 3. And that's L double prime. So when I connect, we're going to have J double prime, K double prime, L double prime. So this is what we're looking at here. So that's J double prime, K double prime, L double prime, which is the image of JKL under the translation 5, negative 3. Yeah? So the question asks us to, right, so we want the coordinates. So let's take out the coordinates. So we know that J, whose coordinates are negative 4, 1, K, whose coordinates are negative 1, 1, and L, whose coordinates are negative 1, 3. And when we translate JKL to J double prime, whose coordinates are 1 on the x, negative 2 on the y, K double prime, whose coordinates are 4 on the x, negative 2 on the y, and L double prime, whose coordinates are 4, 0, exactly at 4 on the x-axis. So we have J double prime, K double prime, L double prime, which is the image of JKL under that translation. But let's look at another. So we got question 7 here. So we have this triangle ABC, A, B, C. And we have triangle A prime, B prime, C prime. Good? And this here we have, of course, our y-axis, our x-axis. So we have 1, 2, 3, 4, 5, 6, 7. We have 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. We have 1, 2, 3, 4, 5, 6 on the y-axis. And we have negative, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 on the negative y-axis. So they want us to write down the coordinates of the vertices of triangle ABC. So the coordinates of the triangle ABC, the coordinates are A will be, this is clearly 3 on the x, 2 on the y. So start with x first, so 3, 2. B, the coordinates are, this will be 6 on the x, 2 on the y, so that's 6, 2. And C, the coordinates are 3 on the x, 4 on the y, so 3, 4. Alright, so we have the coordinates of triangle ABC. Write down the coordinates of the vertices of triangle A prime, B prime, C prime. So part 2, triangle A prime, B prime, C prime. The coordinates are A prime, this is 2, negative 3. So that's 2, negative 3. B prime, that is 2, and this will be negative 6. That's 2, negative 6. And C prime, that is 4 and negative 3. So what is the state coordinates of A prime, B prime, C prime? So let's state the coordinates. And they ask us now, describe fully the transformation that maps triangle ABC onto triangle A prime, B prime, C prime. So what is the form of transformation that maps ABC onto A prime, B prime, C prime? So this clearly is a rotation. Alright, it can't be translation, it can't be reflection, it can't be enlargement. So this here is a rotation, so rotating, and rotating in a clockwise direction, so that's clockwise, and of course we're rotating about a center of rotation, that is the origin, and the angle of rotation, because when you're rotating, you have to state the center of rotation, the angle of rotation, and the direction of the rotation. So this is a clockwise direction. The center of rotation is the origin, and the angle of rotation here will be 90 degrees. Alright, so this will be 90 degrees. So this here is a part 3. It is a 90-degree clockwise rotation whose center of rotation is the origin. So it's a 90-degree clockwise rotation whose center of rotation is the origin. And to also prove it's right, you can use a rule for rotation. The rule is this. Alright? And of course we can apply it to A, B, C, and A prime, B prime, C prime. The rule is this. You have X, Y, which is your object. And when we undergo a 90-degree clockwise rotation whose center is the origin, then it's going to be Y negative X. That's your rule. And we can check it to make sure. If it is 3, 2, that's A, then when we carry out the rule, it's going to be Y, which is 2, and X will be negative 3, 2, negative 3. If we have 6, 2, then Y will be what? Y will be 2, and X will be negative 6. If we have 3, 4, carry out the rule, then it means that Y will be 4, and X will be negative 3. If I take 3, of course, negative X, that becomes negative 3. Yeah? So it proves that this rule, which is applicable to a 90-degree clockwise rotation, will apply to the movement of, or the transformation of ABC onto A prime, B prime, C prime. So it is clear that it is a 90-degree clockwise rotation whose center is the origin. This rule is only applicable when the center of rotation, of course, is when the center is the origin. Yeah? Alright, so let's look at next. So we have another. So we have this triangle here, DEF, so D, E, F, and we have another triangle, D prime, E prime, F prime. Of course, we have our axes. This is the origin, 0, 1. This is 3. That is 5, -1, -3, -5. And on the y-axis, we have 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. All right, the question asks, state the coordinates of the point E. So the coordinates of E, part 1, coordinates of E will obviously be, this is 4, so we move X first, and of course X coordinate first, and Y coordinate, corresponding Y coordinate will be 2. So the coordinates of E will be 4, 2. Straightforward. And then they ask us, describe the transformation that maps triangle DEF on the triangle D prime, E prime, F prime. What form of transformation is that? So, the form of transformation here, this here is a, it can be reflection, it can be translation, it can be enlargement. This here is a rotation as well, but moving in that direction from DEF to D prime, E prime, F prime. And that is a anti-clockwise rotation moving in that direction. And of course, this is my center, that is the origin, and this will be the angle of rotation here is 90 degrees. So it's a 90 degree, so it's a 90 degree anti-clockwise rotation whose center of rotation is the origin. Alright? And we can confirm it too using the ruler. We can confirm it using the rule. So we have D whose coordinates are 1, 2. We have E whose coordinates are 4, 2. And we have F whose coordinates are 1, 4. And let's use the rule to tell us something from D prime to E prime, F prime. And the rule for a 90 degree clockwise rotation is if it's X, Y, then that rule will simply be negative YX. Alright? So you want to ensure that you remember that rule, negative YX. Now let's prove it. If D is 1, 2, and you're using the rule negative YX, then this will become what? Negative 2, 1. Let's see if we have negative 2, 1 for D prime. So D prime will be negative 2, 1. So this is negative 2 and 1. Yes, so that's correct for D prime. Let's take E. E is 4, 2. So E prime will be negative 2, 4. Let's check it out. Negative 2, 4. Yes, correct. And F, which is 1, 4, F prime will be negative 4, 1. So negative 4, 1. Yes, correct. So it means that the rule for a 90 degree anti-clockwise rotation whose center is the origin is applicable to the transformation from DEF to D prime, E prime, F prime. So this here is right. Okay, so let's look at another. So we have here, let me highlight the triangle. This is LMN. LMN. And this is PQR. Alright, so we have element, we have the triangle PQR. Triangle element, triangle PQR. This here is, of course, y-axis, x-axis 0, 1, 2, 3, 4, 5, 6, 7, 8. This is negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4. Good. So the graph below shows triangle element and its image PQR. So this is PQR. After an enlargement. So what they want us to do here, they want us to locate the center of enlargement, show your method clearly. So let's locate the center of enlargement. So if we have to locate the center of enlargement, remember the center of enlargement is not always a new origin. Alright, and if we have to determine what is the center of enlargement, this is what we do. We're going to take our ruler and we're going to draw a line from image to corresponding object points. Straight through, so if you want to go with R and N, alright? So R is the image of N, so we can draw a line from R straight through N. From R straight through N, and I can take L and P, good? So P is the image of L, so I can draw a line from P straight through L. And we're going to see where both lines will meet at a common point. And that common point where both lines, both extended lines meet, that represents our center of enlargement. Whose coordinates there are, that's our center of enlargement. So the coordinates there will be 1, 5. So when they ask us for part 1, locate the center of enlargement, show your method clearly. So the center of enlargement the coordinates here will be 1, 5. Okay? Then they ask us next, state the scale factor and the coordinates of the or want us to locate the center of enlargement, which we did, right? So we located it, that's part A. And part B, they want us to state the center, the scale factor and the coordinates of the center of enlargement. So we stated so this is, let me put this as part B. Part A, we have to locate the center of enlargement, which we did. Part B, they want us to state the coordinates of the center of enlargement, which is 1, 5. And they also want us to state what is the scale factor. So the scale factor, which is denoted by the letter K, it's simply the image length divided by the object length. Good? So the image length here we can take, if you want to take RQ and NM, no problem. So we can take that distance from R to Q. How many units we have there? This would be 1, 2, so we have here 1, 2, 3, 4 units from R to Q, or you can subtract 3 from 7, which is 4, so that's 4 units. And we can take NM, how many units we have here? This is 1, 2 units. We can subtract 2 from 4, which is 2. So the scale factor here, it is 2. Alright? So it's going to be image length, which I will put as RQ over object length, which is n. Okay? That will give us 4 over 2, a scale factor of 2. And when the scale factor is greater than 1, it's going to be on the same, both object and image will be on the same side of the center of enlargement. This is the center of enlargement, both down the same side. The image is always bigger than that of the object. The image and object are both erect, so they're both erect. And the image will be further away from the center than that of the object. So when the scale factor is greater than 1, this is what we expect to see with regards to the image in relation to its object. Alright? Right, let's look at another. Right, so we have this triangle PQR. So we have P, we have Q, we have R. That's our center of enlargement there, which will be denoted by C. We have this triangle here. This is P prime, Q prime, R prime. Right? So you see both triangles, and that's the center of enlargement there, which is C. Good? And clearly it's an enlargement. You have an image and you have your object. But the object of the image is of course bigger than that of the object. So you it's an enlargement one time. Use the information on the diagram to complete the statement below. The size of the scale factor is, now one thing to note, anytime the object and image are on opposite sides of the center of enlargement, this will answer part 2. Then you expect the center of enlargement to be a negative value. Anytime the object and image are on opposite sides, if object and image are on the same sides of the center of enlargement, then the scale factor will be a positive value. In this case, we expect to get a negative value. So part 1, state the size of the scale factor. So this will be image length. So this is the scale factor K over object length. Good? And the image here will be R prime, Q prime. And R prime, Q prime will be just simply subtracting, this is going to be 10 subtract 6. Yeah? Which of course will be 4 units. If we count that's 4 units from R prime to Q prime, we can subtract 6 from 10. So this will give us 4 units all over R cube. So we're moving in this direction from R to Q. So this is 2 units moving left. So of course, once it's 2 units moving left, of course it's going to be negative 2. Or you can say moving left from R to Q, so it's going to be 1 subtract 3, which is negative 2. But it's 2 units moving left. So this will be over R cube, which is negative 2. So 4 divided by negative 2 will give us a scale factor of negative 2. And if your scale factor is less than negative 1, then what happens? The object and image are on opposite sides of the center of enlargement. The object and the image, is inverted. You see how it's inverted? The image is inverted compared to the object. The image is magnified, so the image is magnified compared to the object. Yeah? And the image is further away from the center than that of the object. So these are things you need to know with regards to the scale factor. Based on the scale factor, we know the image will look in relation to its object. So the scale factor is negative. So the scale factor is negative because the image and object lie on the opposite side. of the center of enlargement. Right, so you will lie on the opposite side of the center of enlargement, so you expect your scale factor to be negative. Alright, so let's look at another. Right, so we have here, this is, you have A, so you have capital A, we have our center of enlargement, C whose coordinates are 6, 6, so that center of enlargement is not at the origin, so of course remember your center of enlargement is not always at the origin. And you have your y-axis and x-axis. This is 0, 2, 4, 6, 8. This is negative 2, negative 4, negative 6, negative 8. This is 2, 4, 6. This is negative 2, negative 4. Good? So you have your y-axis, your x-axis. And what they want us to do is they want us to on the diagram draw accurately each of the following transformations. The enlargement of letter A by scale factor 2 about the center 6, 6. So an enlargement of A, alright, of scale factor 2. So you want us to draw an enlargement of A. So that's A there, capital A. Whose center is 6, 6 and scale factor 2. So enlargement, scale factor K, which is 2, center 6, 6. So that's what I want us to draw for A. Alright, to show an enlargement of that capital A. And to do that, what we have to do is simply count the positions from the center. You know, so the position from the center here, I'm going to count, so you can represent it as a translation. This will be, let's take this point, let's take 3 points. What I'm going to do is I'll label the points. Let me call here X, let me call here Y, let me call here Z. Good? So, if I'm translating X, of course this will be translated from the center to X. This will be negative 1, negative 2. So I'm moving 2 to the left and I'm moving 2 downwards. Negative 1, negative 2. So the translation to X, it is negative 2, negative 2. Yeah? But because the scale factor K is 2, I'm going to multiply negative 2, negative 2 by 2 to give me negative 4, negative 4. That will give me X prime. So the translation for X, good? It is negative 2, negative 2. And therefore the translation for X prime will be to multiply negative 2, negative 2 by your scale factor 2 to give you negative 4, negative 4. So let's move from our center of enlargement 4 places to the left and 4 places downwards. So this will be 1, 2, 3, 4 to the left, and I'm moving 4 downwards. This is 1, 2, 3, 4. So this here will be, let me call it W instead. So I'm confused here. Let me call it W. So W and W prime. So that's W, and this will be W prime here. So that's W prime. Let's do the same for Y. So y, so the translation for y from the center x will be what? 1, 2, 3. So we're moving 3 to the left, that's a negative 3. And let's move downwards. This is 1, 2, 3, 4. So that's moving 4 downwards, that's negative 4. So y prime, the translation to obtain y prime from my center will be, I'm going to multiply the translation for y, negative 3, negative 4, by the scale factor 2 to give me negative 6, negative 8. So let me move from my center 6 to the left and 8 downwards. So this will be 1, 2, 3, 4, 5, 6. 6 to the left. Let me move 8 downwards. This is 1, 2, 3, 4, 5, 6, 7, 8. So this here will be y prime. And let's take now z. This is y. That's a y prime, right? Let's take z now. The translation for z from your center whose coordinates are 6, 6 will be what? This will be, I'm moving 1 to the left and I'm moving 1, 2, 3, 4 downwards. So if I'm moving 1 to the left, that will be negative 1, and I'm moving 4 downwards, that's negative 4. So it means that z prime, the translation for z prime will be, of course, I'm going to multiply the translation for z by the scale factor 2 to give me negative 2, negative 8. So let me start from c and I'm going to move 2 to the left and 8 downwards. This will be 1, 2 to the left, and 1, 2, 3, 4, 5, 6, 7, 8. So that's z prime. So when I connect, this is what we're going to get. We're going to have okay? And this will be an enlargement of your capital E, which I've labeled in terms of vertices W, Y, Z. So this is W prime, Y prime, Z prime. Yeah? Using this process of translation. And then they ask us now the translation of letter A using, alright, so they actually want us to now translate your letter A. So this is part 2. So they want us to translate that letter A using the translation vector negative 3, 2. So let's translate that letter A to negative 3, 2. So this will be, I'm going to move, because it's negative 3, I'm moving to the left and 2 upwards. So this will be, I'll remove these dotted lines here. We remove W prime. Good. So I'm going to be moving. I want to translate the letter A, capital A. So negative 3, 2. So I'm moving 3 to the left. 1, 2, 3, and 2 upwards. 1, 2. Alright, so this will be 1 point. So I'm going to move 3 to the left, 1, 2, 3, and 2 upwards, 1, 2. And I'm moving 3 to the left, this is 1, 2, 3, and 2 upwards, 1, 2. And this is translating capital A, 3 to the left, and 2 upwards. Alright? So, this will bring us to the end of this session in relation to transformations Please like, share, and subscribe to the channel. Make sure you share with your friends. Make sure you look at the channel to ensure that we are clear on what is being done as we prepare for the exam that is in the next few days. Alright, so see you on the next episode, and the next episode most likely is going to be matrix transformations. Alright, so have a good one.